Solving absolute value inequalities part B. So what we're going to do is build on the last lesson, and it's going to be very similar to what we did with solving absolute value equations, which we want to remember. You need to isolate, the absolute value first. So what we have right here inside the absolute value needs to be completely by itself. So what I'm going to do is do my inverse operations, right? I'm going to add 5 to both sides. Bring down what's left over, and then divide by 3. And now I can see, do I have a solution, right? Can I keep going? Remembering from the last lesson, if this is a less than sign and it was a negative, then it's no solution. If it's a greater than sign and this was a -7, then we just stop at all real numbers. But since this is a positive, we are good to go. And remember, if it helps, you can always imagine this on a number line to help you remember how to create your compound inequality. So what this is saying is whatever 2f minus 3 is, wherever it ran, it went more than 7 away from 0. So if this is 0, and this is 7 and -7, just doing a quick sketch, more than 7 away has to be out away from 7, so that's where 2f minus 3 went, or it's got to be at -7 and again running to the left. And again, this is where 2f minus 3 is. So I see this is very visibly an OR inequality, right? A compound OR inequality. So I can go ahead and now create that compound inequality. So I'm less than -7 or greater than 7. And then we can solve just like we did before with our regular compound inequalities. And remember, you don't actually have to draw that number line. That's just in case you like to visualize it and see what that means. I think it's actually great to help you understand what absolute value inequalities are. But again, that first number line is optional. We do want to graph our solution, which is not optional. So let me finish solving this. Don't forget again, like in our compound inequality work, you got to bring down that word or to be finished with the problem. So now I'm going to go ahead and take that and graph it. Remember, you can use whatever scale you want on your number line. You can probably go by 2s and make it fit. And remember, if your number you're trying to graph isn't on your number line, just sketch it in, right? So I'm going to put 5 right here and put the number above it so I know what number that is, and then do my graph, right? Okay. Then part B, same deal. Isolate that absolute value first, right? So think about what we're going to do. We're going to go ahead and add 6 to both sides. And then divide by 2. And remember, fractions are 100% okay. Fractions, decimals, you know, they're all numbers too. And remember, if you don't like dealing with this fraction because it's over 2, we know it's going to be something 0.5, so you can change that to 1.5 if you like. And again, if it helps you visualize what to do, sketch out a quick number line and think about what absolute value means. So I know whatever d plus 5 is, it's less than 3 over 2 spaces away from 0. So that means if I'm starting on the right, I'm going all the way up to 3 over 2, but not quite there. But I want to head backwards towards 0, right? Same deal with the -3 over 2. If d plus 5 ran over to the left, he's not going to go past -3 over 2 because he wants to stay less than 3 over 2 spaces away from 0. So we're going to go in towards 0 again. And this becomes an and inequality. So d plus 5 is somewhere in between that. So then I can translate that into the problem I need to solve. And remember, once you get that compound inequality, the absolute value goes away. So don't keep bringing those bars with you. All right, and then just solve like you normally would. And again, if you wanted to change that to a -1.5 and a 1.5, that would be perfectly fine. I'm going to go ahead and change that -5 into -10 over 2. So this turns into -10 3 over 2 minus 10 over 2. And this turns into 3 over 2 minus 10 over 2. And then I can just add or subtract across the top to get negative 13 over 2 and negative 7 over 2. Don't forget, if you need to flip your signs, right? That's always something to think about. We don't here because we didn't divide or anything, but I wanted to mention that. And if this, again, helps to change it into a decimal to graph, this would be negative 6.5, and this would be negative 3.5. And then let's go ahead and graph our solution. So remember, this second graph that I'm drawing is non-negotiable. You've got to graph this. And you can go with, anything you want in terms of your scale. So, for example, I might want to go negative 7, negative 6, negative 5, negative 4, negative 3, and then it goes by, 0.5s. So I've got negative 3.5 right here, and negative 6.5 right here, and connect them, and we're done. Okay? So I want you guys to go ahead and try 1, 2, and 3, remembering we have special cases and remembering when to flip your sign. So those are two tricky pieces, which I'm giving you a clue. It's going to show up in 1, 2, or 3, or in a couple of them. So take a moment, try those out, and then we're going to check your work. If you need to go back and pause to copy down my work, feel free to do that. Don't forget, you can always pause. So go ahead and check your solutions. You'll notice I didn't actually work out everything. I showed you how to isolate each, and then I just went ahead and gave you the answers and the graph. So if you don't know how to solve, for example, this part right here, n plus 1, and the absolute value is greater than or equal to 2, come back and ask, please. And remember, again, like I was saying, you've got to remember when are there all real numbers as your solution, like in number 1, versus no solution. And also, like number 3, you're going to end up dividing by that negative 3 in front of g, so you'll notice my signs flipped. You can go ahead and write your answer either as what you see here on the left or what's over here on the right. I personally prefer this because I find it easier to graph, but again, it's kind of up to you. Okay, we're going to practice this in class. We're also going to finish with the word problem. Again, come back with questions. I'll be happy to go over any of these with you.